So circles section 2 is going to be about angles formed by secant and tangent lines. So you learned those vocabs a while ago. Secants are lines that they're lines. They pass through the circle and they hit at 2 points. Tangents could be lines, segments, or even rays, but they only hit the circle at 1 point. So we're going to cover 3 broad cases here. We have the first case where we have a vertex on the circle. This one should look familiar because this is what we've been doing for inscribed angles. This case here has a vertex inside the circle, but not necessarily at the center. So the center could be off from where the vertex is. And then this third one has 3 different cases within that. This is when the vertex is somewhere outside the circle. So we'll cover each case in turn. You might want to copy down those examples. So first one, this is a special case of an inscribed angle, so I wanted to go ahead and start with that. If you notice its vertex is on the circle, we're going to treat it the same way. This is the reason why this is special is because you can have obtuse, which we couldn't before when we had the 2 secants. So if it was crossing like this. So this one is a tangent and a secant, if I continue that through. So we can have an obtuse angle here, but we'll have an acute one here. So this gets solved the same way. The angle is half of the arc. So you see, solve it the same way. So just a quick example, when you see it like this, our arc here is 120. So x equals half of 120. So x equals 60. A lot of times you'll see the line continue off the other direction, and you could also solve for that one. So this is one of our new ones. These are 2 secant lines that intersect. If I continue these 2, that's where we see our secants, even though they chop them off and make them chords here. So just to summarize, we're going to take half the sum of the intercepted arcs. So if I want to know this angle in here, x, I'm going to take this arc here. You don't really need the middle letters because these are both minor arcs. Take this arc AC, add it to DG, and then divide by 2 or multiply by 1/2, whichever way you like to think of it, and that'll give us this angle here. So quick example of this, if I'm looking for x, now keep in mind that x and e being vertical angles will be the same. So I'm going to add 170 plus 70. And I'll take half of that. And so I'll get 120 degrees. If I want to solve for the other side, if I wanted to solve for this angle, I could use these 2 arcs, but I'm not given measurements. Or I could use the fact that this is a straight line and subtract my 120 from 180, and I would get 60 degrees. So if this is 120, this is 60. Notice there's not really a direct relationship. This is 120 and 170. This one will be 120, and that's 70. So there's not something you'll see right away like it's half or double like we were doing with inscribed angles. So you have to go through this whole formula over here. If we are outside the circle, there are 3 cases, but luckily they all get solved the same way. We're going to, let me actually scoot this over for a minute. We're going to take, just to sum it up, you're going to take half of the big arc minus the small arc. They won't always be major versus minor. Like if you look at this one over here, these are both minor arcs. So it's just, we'll take the larger minor arc minus the smaller minor arc. I could add that the big arc will always be the far one, and the small arc will be the near one. So we have this one's farthest away from the angle, and this one's near to the angle. A quick example of this, since all three get solved the same way, I'm not going to go through an example of each. We're going to take 1/2, so x equals 1/2 of 80 minus 20, so that's different from when they meet inside the triangle, or inside the circle, you add them, but if they meet outside, we subtract. So x equals 1/2 of 60, so x equals 30 degrees. I want you to try this example, which uses the same scenario. We have an angle that has its vertex outside the circle. This is our far arc, and it is 158 degrees. Here's the near arc, and that's what you're solving for. Actually, let me make that a little bit easier to see. So this arc is what you're solving for. And we're given that the angle over here is 68. So let's see if you can figure out how to solve for the arc when you're given one arc and one angle outside the circle. Answer that on your notes, and I'll be able to check that. If you label it, try it yourself, or example 4, whatever you want to label it. So as always, you should summarize maybe 1 or 2 sentences about these 3 new cases of angles in triangles, or angles in circles. And if you would like to leave me a note to amuse me while I check over these, you could tell me something, one of your least favorite things that a teacher can do, because, sometimes I forget that, I do things that can be pretty irritating to students, like letting you practice one set of angles and getting them really good, and then adding new, slightly different angles to the circle. So give me a summary, give me a fun story if you want to, and don't forget to ask any questions if you didn't understand something.